Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the alpha carbons. The carbonyl group C is equal to O at C4 has two sets of alpha carbons. Alpha carbon on the left side, C3, the CH2 adjacent to C is equal to O on the ethyl side, i.e. CH3-CH2 side. Alpha carbon on the right side, C5, the CH2 adjacent to C is equal to O on the propyl side, i.e. CH2-CH2-CH3 side. Moving on to the next step. Enol formation by removing H from left alpha carbon, C3. This gives CH3-CH is equal to C, or CH2-CH2-CH3. The double bond is between C3 and C4. C3 was CH2, two H is removed one at a time, but when we form the enol, C3 becomes CH is equal to and C4 becomes C, or is equal to. C3 in the enol, CH3, CH is equal to, so C3 has one H and is connected to CH3 and C4, or is equal to. This double bond, C3 is equal to C4, C3 is connected to CH3 and H, C4 is connected to O and CH to CH to CH3. This gives E and Z stereoisomers because both carbons of the double bond have two different substituents. C3, H and CH3. C4, O and CH to CH to CH3. So this gives two enols, E and Z. Moving on to the next step. Enol formation by removing H from right alpha carbon, C5. This gives CH3, CH2, C, or is equal to CH, CH2, CH3. The double bond is between C4 and C5. C5 becomes is equal to CH with one H, C4, connected to O and CH to CH3. C5 connected to H and CH to CH3. Both carbons of the double bond have two different substituents. C4, O and CH to CH3. C5, H and CH to CH3. This also gives E and Z stereoisomers to more enols. And for the final step, total enol forms is equal to 2 from left alpha plus 2 from right alpha is equal to 4. Why other options fail? A. 2 counts only one direction of enolization without stereoisomers. B. 3 undercounts, misses one stereoisomer pair. D. 5 overcounts, there is no additional site of alpha deprotonation. Therefore, the correct answer is C. Therefore, the correct answer is option C.